This is 7.1a of geometry, and we're going to talk about ratios. So a ratio is a comparison of two quantities by division, and there's three different ways we write them. So you either write them, let's say our ratio is 3 to 2, okay? So I'll write it up over here. You can write it as 3 to 2 with a colon. You can write it as 3 to 2 with the word 2 in between. Or you can write it as a fraction, 3 over 2. Okay, three different ways we can write them. So, let's look at our example here. We're going to skip to our got it problem. It says a bonsai tree is 18 inches wide and stands 2 feet tall. What is the ratio of the width of the bonsai to its height? So, when we're working with ratios, we need to be in the same unit. So we don't want to keep inches and feet. In my opinion, it's easiest to switch from feet into inches. So let's convert down here. So we've got 2 feet, and you can just stick it over 1. And we're trying to get out of feet and into inches. So whatever you're trying to get rid of, see how my feet's up here on the top? If I'm trying to get rid of feet, I need to then put it on the bottom. So 1 foot will go on the bottom, and I'm trying to get into inches, and 1 foot is the same thing as 12 inches. We're allowed to multiply by this, because this is essentially 1, right? This is like 1 foot over 1 foot, except for we're just changing the units. So when we multiply, our feet will cancel off. And so if we multiply straight across, we get 24 inches over 1, which is just 24 inches, right? So it asks, what is the ratio of the width of the bonsai to its height? So width needs to come first. So we've got 18 inches to 24 inches. And here's two other specific things about ratios. We want to put them in simplest form, and we don't want to use units. So we're going to take the inches off of that. So 18 to 24. And then I can divide each of these by 6. So I get 3 to 4. Or I could rewrite that as 3 to 4 with a colon, or 3 over 4 as a fraction. And those 3, whatever ones you want, however you want to say it, is your answer. Okay. So, members of the school band are buying pots of tulips and pots of daffodils to sell at their fundraiser. They plan to buy 120 pots of flowers. The ratio, with number of tulip pots on top and number of daffodil pots on the bottom, will be 2 to 3. How many pots of each type of flower should they buy? So, whenever we're working with ratios, I personally like to switch it over to the one with the colon. That's just how I can think of it easier. And then when we're talking about ratios with objects in a total, this means for every 2 tulip pots, we want there to be 3 daffodil pots. And we can stick this into an equation by just sticking an x with each of those numbers. So 2x plus 3x, and it needs to equal the total 120. And then we can solve it, which you can see in this work here. So let's try our own problem. It says the measures of 2 supplementary angles. Think back, what does supplementary angles mean? That means that they add to 180 degrees. So the measure of 2 supplementary angles are in the ratio 1 to 4. What are the measures of the angles? So we're going to stick an x with each of those numbers. So 1x plus 4x equals 180. So we can simplify on the left. We get 5x is equal to 180. And when we divide both sides by 5, we get that x is equal to 36 degrees. So that's not my final answer. We want to know what are the measures of both angles. So I'm going to plug them in. I'm going to do 1 times 36, which is just 36 degrees. And then I'm going to do, 4 times 36. Which gives me 144 degrees. And you can double check, and they do in fact add to 180. We can do that same sort of thing this time with an extended ratio. So an extended ratio compares at least 3, sometimes more, numbers. And it's gonna look something like A to B to C with colons. We could use the word 2 as well, but we can't really write that as a fraction, right? It's not gonna make sense. So usually you'll see it with colons. And we can use the same sort of thing as we did in the last problem where you just stick an X on it. So let's look at our bottom got it problem. says the lengths of the sides of a triangle are in the extended ratio 4 to 7 to 9. The perimeter is 60 centimeters. What are the lengths of the sides? So I'm going to rewrite those numbers but stick an x with them. 4x plus 7x plus 9x. And those are the sides of a triangle, and I know that they need to add up to 60. So when I add them up together, I get 20x equals 60. And if I divide by 20 on both sides, I get that x is equal to 3. Remember, that's not your final answer. They ask, what are the lengths of the sides? So we got to go back in and plug them in. So 4 times 3 gives us 12. 7 times 3 gives us 21. And 9 times 3 gives us 27. So, and that was in centimeters, so all of these are centimeters. And there you go. There's your homework.